Hello and welcome to this video where I'll be discussing different ways to visualize data in the R package ggplot2. To get straight into it, the data I'll be using is a mini ANES dataset comprised of individual level data. This survey was given out and records a bunch of different social, economic, and demographic variables. For those completely unfamiliar with ggplot, the core syntax looks a little something like this. We'll write ggplot, give the name of our data, write AES for aesthetics, and then just give the name of our variables. After that, we'll write plus and come down to a new line, and then write geom underscore ... And this is where we'll put in geom histogram, geom box plot, geom violin plot, etc. Let's now move to a real example and start on some summary statistics. So we'll start with that ggplot, give the name of our data, which is MANES, aesthetics, and I want to find out what people feel about scientists. Come down to a new line, give geom, and let's start with a histogram. So at the very basic level, R will spit out something like this. While it works and we can see that generally people have a positive opinion of scientists, the graph doesn't look very good, and there's a lot of things we can do to make this better. What's really bugging me about this graph is the bad labels. So to change that, we can use the labs command and give labels to each of our axes along with a title. So for our x-axis, let's do something like temperature for the feeling thermometer. We can keep the y-axis the same as count, but just capitalize it. And then for our title, we can do something basic like feeling thermometer of scientists. And that'll spit out something like this. While it's definitely not great, it's a lot better than before. While those labels are nice, there's also more I want to substantively change with this graph. First being how wide the bars I have are. And I can do that pretty easily with the bin width command. It's pretty easy to play around with, but I think something like 6 is going to look nice. I think changing the bin width did a really good job at making this more cohesive, and I think we can move into some more aesthetic stuff. First, I want to give this graph a theme, and I use the theme BW command to make it black and white. ggplot has a ton of native themes, and I'll leave a link below to a page that has a bunch of them. Continuing these aesthetic changes, I'd like to add some color into this graph. I can do that pretty easily with the fill command, and let's add dark blue. I think this blue looks really nice on its own, but I want to be able to better differentiate between the bars, especially in areas like this. To do so, we'll have to change the border colors of each of the bars. We can change the border colors pretty easily with the color command, and I think adding white will make them stick out a lot more. This graph is doing its job, but there's more I'd like to do. I think introducing a second variable will make this a lot more interesting. As an example, I'd be really interested in seeing how this looks, but broken down by party. However, there's a few things we have to do first. Within my dataset, there's a really easy variable for party called PID3, which measures if people reported themselves as Democrats, Independents, or Republicans. However, we have to vectorize that data because right now it's just coded as 1, 2, or 3. To do that, we'll use this line of code. This recode factor command is going to come in really handy for a lot of what we want to do. R can be a little picky if you're telling it to sort by groups that are still numeric numbers, so to change that, we use this recode factor command to change the 1 into a Democrat, a 2 into an Independent, and a 3 into a Republican. This is nice because PID3 is already coded like this, so we don't have to change anything with the data itself. Now that we have our recoded variable, we can make a new set of histograms with 1 for each party identification. This new code is definitely a little bit more complex, but it's essentially just telling R to make a subset of our current data based off of a PID3 variable, but without any NA responses. We'll have to add an additional argument to actually split the plots up, but for now we can steal the rest of the code we wrote before with just a few minor tweaks. Because we're now splitting the plots up by PID, we're going to want to remove the fill and color arguments as we're going to put those somewhere else. In order to give our graph some color, we're going to move the fill argument up to the aesthetics tab. Setting fill to PID3 tells R that we're going to fill the colors based on the PID3 variable. Now that we've told R we want this graph to be colored based on the PID3 variable, we actually have to input those colors in a separate line. To do this, we're going to use the scale fill manual argument, which allows us to set custom colors. With this argument, we can now tell R exactly what colors we want. We'll set values equal to C and then open a new bracket. I already have my colors selected over here, and I'll insert them now. While this might look weird, ggplot has a couple different ways you can use colors, one of them being hex codes and one of them being their own custom color set. Hex codes are pretty widely used, but R's color set may be a little difficult to find, so I'll leave a link below to all of their available colors. With that being said, we can now run this code and see what it spits out. Obviously, this graph doesn't make much sense on its own, but remember there's one more thing we can do to split these up into 3 different groups. Here's where we'll use the facet grid command and tell it to use PID3 as our variable. We'll add a plus sign to connect this to the rest of our code, and then when we run it, we get 3 evenly spaced out plots based on our PID3 variable. This graph looks really nice now, and there's only one small change I'd make, and that's removing the legend. We can use the guides command and tell it to fill equals none. Add a plus sign to connect it, and then run it. I chose to remove the legend in this graph because I feel like it's a little bit redundant. Each of our plots are already labeled with their correct party, and the color helps to show what they are. I'd say this graph is done now, and I think it's time to move on to something else. I'd like to touch on density plots next, which are just a different way to present summary statistics. Thankfully, because of how widely applicable the ggplot syntax is, we can again steal almost all of our code from before. All we're going to change here is getting rid of our bandwidth argument and changing histogram to density. When we run this, we'll get our basic density plot. There's a couple changes I want to make here, one of them being how steep the slopes and valleys are in this plot. Due to the nature of survey questioning as a whole, and the survey questions my data is built off of, some numbers are overrepresented in this plot. For example, while a lot of people might feel 100 out of 100 about scientists, this large dip doesn't mean that people's opinions rapidly cool. What this means is that people are just less likely to say 92 or 93 out of 100 when asked a survey question on a scale of 1 to 100. In order to smooth out some of these large bumps, we'll use the adjust argument and put it in the geom line. We'll set it to 1.5 to start and work from there. Without modification, the adjust argument has a base rating of 1, where anything higher than 1 will make the graph smoother and anything less will make the graph sharper. Once again, for a basic graph, this does its job, but there's more exciting things we can do when we introduce a second variable. I'd like to reintroduce the PID3 variable here and have each party represent its own plot overlapping each other on a graph. Thankfully, we can again reuse our code from before and just make the same changes to it. We'll change histogram to density. We can get rid of our bandwidth argument, and we can scrap the guides and facet grid arguments because we want these plots to overlap. What this leaves us with is 3 density plots overlapping, but there's more changes we need to make. In order to actually make these plots see-through, we'll have to introduce a new argument, alpha. We'll set it to 0.5, and additionally reintroduce our adjustment argument, and keep that at 1.5. When we run this, we'll see that we have 3 overlapping plots where you can tell the density for each party at a given temperature. This graph is pretty much done, and I only want to change some small things. For one, I want to change count to density again just for correctness. And I'd like to add white to the borders instead of black. I think it'll look nicer. Visually, I think changing that to white looks a lot better, and I think it's a bit less obstructive as well. The final change I want to make here is to actually get rid of our legend title. It's a bit repetitive given that we already have colors and names that help differentiate between the plots on this graph. To get rid of it, we'll go back to our guides argument. We're going to set fill equal to guide legend, and then open a new bracket and set title equal to blank. After that, we can add a plus sign and run it. We're left with a really nice graph now, and I think it does well to show the distributions of opinion based on party. I'm really happy with how this graph turned out, and I think we can move on to a different way to represent summary statistics. The last 2 summary plots I'm going to cover, box plots and violin plots, are pretty similar, and a lot of the changes we've made in these first 2 are applicable to the next ones. For both box and violin plots, I'm going to skip over the basic plots we've been making and jump right to our PID3 plots. Like before, we're going to be stealing a lot of the code we've already written, so I'm going to copy this over into a new line. Like before, we're going to have to make a couple changes before we can run this. First, we're going to change the density argument to box plot and open a new bracket. Additionally, we're going to get rid of this density title. We can get our basic plot now, and it looks pretty nice. Before I can call this graph done, there's just a few changes I have to make. First, I'm going to introduce PID3 as the y variable. This is going to get rid of these numbers on the axes and change them to Republican, Independent, and Democrat. Additionally, I'm going to introduce the notch argument. This is going to create a notch on the medians and have a confidence interval around them. When we set notch equal to true and then run the graph, all of our boxes will have these little notches on them, which indicate both the median and the confidence interval. What I like about this notch argument is that it's aesthetically pleasing and it serves a purpose. It looks nice, and it also tells you if your medians are statistically different from one another. The last change I'm going to make to this before jumping over to violin plots isn't one that's entirely necessary, but rather just a different way to represent what we've already made. By using the chord flip argument, we're able to flip the x and y axes and present this vertically. We can start working on violin plots now, as we'll only need to change one line of code. As you might expect, we're just changing the box plot line. We'll get rid of our notch argument, and we'll change the box plot to violin. While they're not my preferred graph, I think violin plots are pretty cool, and you can think about them like density plots, but just mirrored over an axis. Because of their similarities, a lot of the arguments that we used in the density plot example are applicable here. For example, we can use adjustment again. These curves might look a little similar now, and that's because these graphs are representing the exact same thing the density plots did. And if we go back to this example, we can see those curves represented here. That's all I have for representing summary statistics, but stay tuned as in the next video I'll be covering bar graphs, line graphs, and scatter plots.